there are some general rules of domestication about what happens to the domesticated animal compared to its wild variant. So the first thing is that it reduces in size, which is somewhat counterintuitive because you'd think, well, it's got a wealth of food. Well, being in captivity, why would it get smaller? That doesn't make any sense because the wild animal has to actually work for its food. It doesn't get it delivered to it in the same way. But of course, if you're selecting for size, in the case of, say, a cow, where you want as much meat on there as possible, obviously that doesn't happen. So this is a general rule. But if something is being bred into them, like cows are not bred to be smaller, that's for sure. They're bred to be bigger. And therefore that doesn't necessarily apply to them. But generally speaking, when you domesticate something, make it less aggressive towards humans, that's generally speaking what we mean by domestication, as in you're able to keep this animal without it trying to attack you. So purely in that sense, these things would probably shrink. But there are, of course, other things because they didn't just domesticate them to have them around as pets. They wanted them to do stuff. That's why, say, border collies are very intelligent because they have to round up sheep and things like that. They've got a specific role. It's why terriers like to chase really small mouse or rat-sized objects because that's what they've been bred to do. It's deeply lodged in their brains. So another thing is a short face and small teeth. This is something that is seemingly true of lots of domesticated animals. It shrinks the size of the face and makes the teeth smaller. I suppose smaller teeth is just an adaptation to better feed, maybe, I don't know. There are lots of different reasons for this. But it also, something that I thought was interesting, makes something look cuter to human beings, which might be part of the reason that it's been bred in that way. Because if you're selectively breeding something to be receptive to you, I'm thinking particularly dogs, well, you want them to look nice. You want them to not only be friendly towards you, but you want to be friendly to them. And if they look really ugly and horrible, and there are some dog breeds that certainly fit the bill there, you might not want to pet them as much. So another factor is reduced sexual dimorphism, which just means the difference between the size in men and women. So I've used the example in the past of baboons, where the baboon males are massive and the females are quite small. And then you can look at other primates, like bonobos, for example, where they've not got nearly as much of a difference between the two. And there are lots of implications for that, in that if there's reduced sexual dimorphism, it normally means that there's more free love, to borrow the terms of the hippie generation, in that they're more likely not to be monogamous and they're more likely to engage in things like homosexual sex and things like that, which does occur in the natural world. Again, using the example of the bonobo, which I'm going to mention quite a lot.
It's interesting because there's a relatively high amount of sexual dimorphism in humans, isn't there?
There is, but relative to other primates, it's probably less than is usual.
But relative to the entire animal kingdom, because most animals really are sort of almost identical. Lots and lots of animals, they're sort of almost identical. You know, like I'm thinking across the entire animal kingdom.
Yeah,
I'm talking about.
And I'm not entirely sure whether it's. I know it's certainly true of primates. I'm not sure whether the applicability of this understanding becomes weaker when it's applied to other mammals. But I think it still seems to hold, as far as I'm aware, because of course, when you have a large amount of sexual dimorphism, it normally means that the male has specialised into some sort of niche to win over. I'm thinking of, say, is it a lyrebird or something like that? I might be thinking, no, it's the birds of paradise, that's it.
Okay, right.
Yeah, where
the
males are very, very colourful and it's all about competing with one another, whereas the females look relatively ordinary. They look kind of like a female blackbird. They're kind of brown and small and unassuming. And it's because there's a difference there, because there's a niche and they normally mate for life, as far as I understand.
Well, like a peacock and a peahen. It's the male, the peacock, that's got those incredible tail feathers. A peahen is nowhere near as spectacular.
Yeah.
There are some examples where the female is bigger. I'm thinking the immediate thing I think of is a black widow. Famously, the female is massive and the male is tiny. But
I think that's true of lots of insects, though, isn't
even
it?
in mammals, though, like I know the blue whale. I believe the female is bigger than the male in blue whales.
It's certainly there's no written rule where the males are always largest.
Right. So just as a very quick aside note, interested in what would be the biggest blue whale? It would be a pregnant female with gigantism. Anyway,
I'm glad we've got that settled.
yeah. There's something else I wanted to say though about just to go back ever so briefly, but still the same point we're making here. But on the gene side, because of course I'm no expert in the human genome or sort of gene science or anything, but it does seem that you need a relatively small amount, or really a tiny difference or mutation in genes for it potentially to play out to be quite a massive difference in the real world, in real time. For example, there's one example where butterflies can change their colour in like one generation due to external, due to the external world. You know, you must know the example where the trees became very sooty during the Industrial Revolution.
That's a moth, isn't it? I forgot the name of the moth.
Right, but you know, anyway, the point of all that is to say that, I know it's only moths, and it's a quite simple example, but it can happen quite quickly. It doesn't necessarily take millions of years.
It does depend on what the trait is and what the animal is as well, because for an animal that relies on camouflage in a changing environment, there might be a bit of an incentive to have very changeable genes in certain areas and fixed ones in others. And I think that that's probably what's going on with those butterflies and those moths, is that they can change that aspect of themselves quite easily. And it's not like if a human being moved to a different habitat, they would necessarily change. It would take many, many generations of natural selection.
If you allowed the natural selection to play out just, naturally, rather than, a lot of the things you were talking about there, having a smaller face and smaller teeth when things become domesticated. I was just thinking of dogs largely.
Yeah. I think that's a good example for it as well, because it's very clear most dogs don't have teeth like wolves. Yeah,
it was very interesting. I saw an anecdote being told. I think it was on Joe Rogan, actually. And he was, or I can't remember if it was Joe Rogan himself or his guest, talking about lap dogs. How what they would do is a dog would have a litter of puppies. And when the puppies were really still quite small, they would do a simple test for aggression, just sort of poke them or roughhouse them about a bit. And any dog that showed any aggression, they just kill it, get rid of it. And the ones that were docile and didn't do anything, didn't react, they're allowed to live. And within very, very few generations of that, half a dozen generations or less, you've got only docile lapdogs. It's very, very, very quick. And of course, if you leave natural selection still on its own, it could take.
It would trend probably back towards the aggression.
It
again,
might do,
it?
Right? Yeah, you never know. There's another great story from I think it's The Ascent of Man, where they talk about in Japan, in a particular bay in Japan, there's lots of crabs, and there's like a pattern.
I know this,
I'll just tell everyone out there.
Of course,
There's a pattern on the shell of the crab that looks like the face of a samurai, quite specifically the face of a samurai. And it was just purely where the people over a few hundred years, the people, whenever they saw a crab that seemed to have that pattern on its back, they would throw it back and allow it to live. For no other reason than a sentimental reason. There's no other reason than that. And anyway, hundreds of years later, but only a few hundred years, they're the only crabs. The normal crab with a plain shell of that species didn't survive at all. And you're left with, and it became more and more specifically samurai-looking face. Not just a bit, not just sort of vaguely resembled it, but it looks really like a samurai face of a samurai warrior.
I find that story really quite compelling, isn't it?
Yeah,
it's a very clear demonstration of what's going on here.
Yeah.
And how humans can have a hand in it, even unintentionally.
Right, yeah. Sorry, I've got a little bit away from your point. Sorry.
But there are two other main traits that change with domestication. There are changes in fur colour and texture. Normally the fur gets fluffier, and quite often the colour changes. So in in dogs and other animals in particular, you get mixtures of different colours or spottiness or things like that, which tends not to occur in nature. When you see a wild dog in nature, for example, in, say, Africa, the colours are adapted for its environment rather than, say, a dog that is bred in, say, Britain sticking out like a sore thumb because it's black and white or something like that. Whereas that's not going to make it very camouflaged in the environment.
Yeah, no, it's very interesting, isn't it? Like how even people find that some dogs, or not even dogs, could be horses or cattle as well, that they think it's cute that they look like they're wearing socks, right? So you have a dog that, or it can be a horse as well, that you want it to be completely tan but with white socks. And so you breed for that, and quite quickly you get exactly what you want. And yeah, the idea of a Dalmatian, for example, that just doesn't... You get all sorts of animals with stripes, don't you? Tiger stripes, zebras, but the idea of spots, like a Dalmatian, again, that's very specifically... It's been very specifically bred for that, hasn't it?
Yeah. It doesn't occur in wolves naturally, we know that much.
Yeah.
So the final thing is smaller brains, and we're going to be looking at that in the human context later on as well. But all of these seem to be unintentional consequences of selecting for less aggression. It changes all of these different things, and you may notice that compared to our ancestors and other apes, we are smaller in size. We do have smaller teeth and a shorter face in the sense of, you know, it's flatter rather than stretched out, sort of elongated like a chimpanzee. We do have reduced sexual dimorphism relative to other primates. I mean, we don't really have a fur colour. We've lost our hair, although that seems to be something that happened millions of years ago. So I don't think that's necessarily part of the self-domestication thing. I don't think that's part of the debate. We know that happened long before human beings existed in their modern form, and smaller brains. You might be saying, hang on a minute, smaller brains? But no. Relatively recently, our brains have shrank. So I'm going to be looking at that later on. But
I must say, just super quick to say that, I found it very interesting when we did that Contemplations on early humans, or it was a couple, wasn't it? That something, if you just take the pure weight of their brain, it would be bigger or heavier than ours.
Yes, that's right.
It's obviously less sophisticated in what it's capable of. But in terms of pure volume or weight, it was bigger or heavier. It's interesting, isn't it? But it goes back to that old thing, well, it's not all about size. I mean, what otherwise...
Size isn't everything, that's right.
Otherwise, a blue whale would be the cleverest thing, right? If its brain is the size of a van.
Car, isn't it?
Right, yeah. And why isn't it extremely intelligent? Well,
it's not all about that. Right, it's about the number of neural networks, more specifically. Yeah, right. The number of folds physiologically.
To watch the full video, please become a premium member at lotuseaters.com.